Now you're gonna write another one. The parameter is the same, it's gotta be at least 1 page type, you know, same, all the rules are the same.
What?
This time though, the paper, what is it?
Elijah and a big old thing of water.
This time around, the paper revolves around Lent. Next Wednesday is Ash Wednesday, and Lent starts. However, this project, I don't want to offend anyone's sensibilities at all. If you aren't a religious person, you're not Catholic, you don't believe in Lent, that's all okay. Well, you're entitled to that. But this project doesn't have to be about that. This is about doing something good for someone else that's going to improve your life and the life of somebody else. Lent lasts for 6 weeks, so I'm going to ask you to do something at least 6 times, the same thing. So here's an example. Every Monday night, you do the dinner dishes. You clear the table, you clean up everything, do the dishes, put away the leftovers. You take care of it every Monday night. You do it every Monday night. That's what you do. Maybe every Thursday night, you sit down with your little brother and help him practice for his spelling test. Every Thursday night, you spend 45 minutes quizzing your little brother on spelling. Every Sunday afternoon, you go sit with grandma for a couple hours, or great grandma, or aunt, or somebody, and talk to, and just visit with them for a couple hours. So you're starting to get the idea. You are making a small sacrifice of time to benefit someone else. Do you understand? Guys, do you understand what I'm saying? You understand what you're doing?
All of those sound like things that are. Every Monday night I'll buy him dinner probably.
Find something new.
Yeah, what's the
Find something new. This is about doing something extra. Now, what are you gonna write about? Well, it's gonna be easy to fill a page this time, guys, because you're gonna, first of all, tell me what you did, but then you're gonna tell me how it impacted the other person. How did it make Grandma feel? What did Grandma say when you started coming to visit her every Sunday? What did your mom say when you started just cleaning up the dinner dishes? And then, how did it impact you? Because I bet you'll find, if you truly do this and don't just fake it, if you really do it, I think you'll find that you feel better about things too, from helping mom or brother or grandma or someone. It doesn't have to be a family member, it can be a neighbor or someone else. I will, at some point soon, put the official prompt and all that in Canvas, but right now, you know what you need to do. Lunch starts next Wednesday. Be thinking. If you have a question, just ask me if you're not sure. And if you have a real ideological issue with doing something nice for someone, talk to me and I'll come up with an alternative thing. I had a kid take nap on that once. Yeah. But I don't want anybody to feel like I'm shoving religion down your throat, because that's not my intent. We're doing it during Lent. We're a Catholic school. We're doing it during Lent, but it doesn't have to have Catholic overtones to it if you have a different belief system. Okay, we good? Perfect.
Are you Catholic?
Huh?
Are you Catholic?
Yes.
What church?
Yeah.
Highest. Okay.
Where's St. Clair's?
72nd.
All right, where are we? We are ready we gotta do 2 or 3 things.
Nope.
We are going to do in our practice packet. Our practice packet, I gave you this a long time ago. Get that back out. Leave your notes out. You need those too. We're gonna do a couple practice verifications, because these are gonna show up on your test, which I think is gonna be next week, that's my goal.
For
next
Wednesday,
week.
right? Yeah.
Yeah, so we can get the recorder right. So we need to practice a couple more of these. So, I am on page 2 of the practice packet. Are we good with that? Okay, so Jake is looking at the problem. If you can't find your packet, just write down the problem on a piece of paper. You gotta get moving. Jake says, I've got 2 fractions that I'm adding together. And when I add fractions, I need a common denominator. Okay? So what would my common denominator be? 1 minus cosine and 1 plus cosine. So what does this one need? 1 plus? Right? And this one needs 1 minus. All right, so now they have the same denominator. So what's on the top? 1 plus cosine plus, actually I don't even need those parentheses, I think I'll take them out, they might confuse us. So 1 plus cosine here and 1 minus cosine here. Well, doesn't take much to see that these are going to cancel. And we have 2 on the top. And then what's on the bottom? Foil it.
1 minus 2 cosine. Oh, no,
1 minus cosine squared?
Yeah.
Because when you FOIL, this is the difference of squares here. So when you FOIL, the outside and inside are going to cancel. Now, what do you know about 1 minus cosine squared? It's something. Tyler says it's something. Yep. That's when we look at our reference sheet, we figure out what something is it.
Sine.
1 minus cosine squared is sine squared. Again, sine squared plus cosine squared is 1. So if you move this over here to this side, so it's 1 minus cosine squared, that equals sine squared. Now, this is not a stretch. This is 2 times 1 over sine squared. Did you agree with that? And what's 1 over sine?
Cosecant.
Cosecant. So we have 2 cosecant squared. All right? Next, we're going to do the second one down there. What do you think about this?
Tangent equals sine over cosine, or sine, you can't sine over cosine. The cotangent is cosine over sine.
So we can rewrite, excuse me, tangent as sine over cosine, and cotangent as cosine over sine.
And then get a common denominator.
Again, we're adding fractions,
Alright.
so we'll get a common denominator, which will be cosine sine. This one needs a sine. And this one needs a cosine. Right, we're making the denominators match. So what do we have on top now? Sine squared plus cosine squared, which is 1. Now again, you have to understand your arithmetic here. This is
One
the
over
same as 1 over cosine times 1 over sine. These are the same thing. And that is secant, and that is cosecant, which is exactly what we wanted. We'll do one more, and then we gotta get back to our notes. We'll do one more. So backside number 3.
Mrs. Ford?
Yeah.
Okay, so when we're like circling our answer, are we like circling what we got at the very end?
Actually, you don't even circle your answer. This whole thing is your answer. So the idea is I should put one more step on here as I was it. So this is secant, cosecant, and it has to match what was on the other side.
So you feel all your work is your.
Yes, your work is.
Yeah, I know that.
Yeah.
All right, one more. Let's see what we've got. All right, so I don't know. Kind of look at the problem. What is something you can think of to do?
Sine squared equals 1 minus 4.
So, looking at what I want to end up with, are there any signs in here? So let's change that. So we'll leave the top alone for the time being. And then the bottom is 1 minus cosine squared. Quick point. You cannot change a regular sign into a cosine. That won't work. The only way you can change them is if they are squared, okay? You can always change a squared, but that's all. All right, so I did that. Now keep in mind, that's where you're headed.
4. You got the difference.
Obviously, what is gonna have to happen here?
Difference is 4.
I'm gonna have to get rid of something, right? So Elijah says, on the bottom, I have 1 minus cosine, 1 plus cosine. It's the difference of squares. What about the top? Can you factor the top?
Yeah, you can pull out like
Well, you can't pull anything out. There's no common pulling things. Wouldn't you have to have a 1 and a 1 here?
Hit a 2 to 2.
And
A 4 and 1. 4 and
yeah,
1.
probably 4 and 1 because I want to end up with a 3.
4 and 1.
So we'll put 4 cosine and regular cosine.
Yeah, that's good. Yeah.
And I need one of them to be negative.
Yeah, that's right.
This is first year algebra factoring, but it's confusing because it's got cosines in it. So always check. If I FOIL this, first times first gives me my 1. Outside is positive 1 cosine. Inside is negative 4 cosine. That gives me negative 3. And then I have my negative 4 cosine squared. So we're factor. And now what do you notice?
Cancel out.
Now we can cancel and we're left with exactly what we were shooting for. Okay? We'll practice some more. We'll keep practicing a little bit every day, but that we need to know how to do. All right, let's go back to our notes then. We're almost done.
No, we have like 5 pages.
Well, no, we're almost done with this first part. We're testing over 5.1 to 5.4. All right, so we're on our notes, page 53. we're finding the sine of alpha plus beta. Alright, so first thing I'm gonna do is I'm gonna look at my reference sheet and I'm gonna write down the formula. What is the formula? On the reference sheet, it's U and V. So this is gonna be sine of the first, cosine of the second, plus cosine of the first, sine of the second. So, step one, write down the formula you're gonna use. It's straight off the reference sheet. If the variables confuse you, change them. All right, you good so far?
Yeah.
All right, second step, draw a picture of the given. So, for alpha, I am going to draw a triangle. And the triangle I'm going to draw is between pi over 2 and pi, which means it's where? It tells me this in the problem. Pi over 2
Second.
to pi
Second.
is here, isn't it?
Yeah.
So I'm going to draw a triangle. This is alpha. This is my alpha picture. It's in quadrant 2 according to the problem. And opposite over hypotenuse is 3 over 5. So guess what I'm going to do?
Pythagorean theorem.
Pythagorean theorem. Find the missing side and make sure you mark it negative because it would be negative in that quadrant.
Negative 14. Where's 14?
Negative 5.
It's 4. 25 minus 9 is root 14.
It's 16.
Oh, 16.
So it's 4.
Negative root 16. Oh, it's 4.
Alright, you got it? Folks, you with us?
Come on.
Alright, now do the same thing for
Right.
beta.
It's front.
Where is beta going to be? Between 3 pi over 2 and 2 pi, which will be quadrant 4. Kids, the problem will tell you exactly where to draw the picture. But what do we know? The cosine, so adjacent over hypotenuse, is 5/13. Do the Pythagorean theorem. This side will also be negative. Pay attention to that.
What's 13 squared?
169.
169. 14 squared, 196. 15 squared, 65.
I got 12 negative.
Yeah, I got the
Now, you're going to take the numbers from the pictures and plug them in to your formula. So the formula says I need the sine of alpha. Okay, here's alpha. The sine of alpha is 3/5. And then I need the cosine of beta, which is 5/13. Are you following?
Yeah.
Now I need cosine alpha, which is negative 4/5. And sine beta, which is negative 12/13. Now, I suggest you don't reduce. I know we could cancel here, but let's not because we're going to be adding. So having a common denominator will be helpful. So this is 15/65 plus 48/65. Negative, negative cancels. So the answer is 63/65. Now, it's a really big problem, but it's not hard. It's not hard. All of the problems on the page use these angles, so I'm going to leave these here. And now I'm going on to problem 2, which is the tangent of alpha minus beta. All right, so let's write our formula. What's the formula for the tangent of alpha minus beta?
Tan A, or tan out, whatever it is,
Minus
tan A,
beta.
beta, over 1 plus tan beta plus tan, wait, no, times tan beta.
Yeah, your variables don't matter. I am using alpha and beta, you can use A and B, you can use U and V, it doesn't matter. Okay, what variables you use. But this is a picture of A, alpha, and this is a picture of beta. All right, so now let's plug them in. So what's the tangent of alpha? Negative 3/4 minus, what's the tangent of beta? Negative 12/5 over 1 plus negative 3/4 times negative 12/5.
So negative 36 over.
Or positive 36.
All right, is everybody with us so far? All right, so now what we need to do, let's do a little arithmetic here. So on top, I basically have negative 3/4 plus 12/5. And on the bottom, I have 1 plus 36/20. Again, I'm not reducing at this point, I'll reduce at the end. Everybody okay getting from here to here? Now, you do whatever you're comfortable doing. Could you get a common denominator up here and add those together? And get a common denominator down here and add those together? And then have a fraction divided by a fraction, so you could invert and, keep, change, flip, all that? I'm going to not do that. That'll work. If you are comfortable doing that, do it. I'm gonna multiply everything by 20. Because if I multiply everything by 20, then I will no longer have any fractions to worry about.
Isn't that kind of like doing the same thing as getting common? It's kind of like.
Yeah, but I'm saving a step in there. But yes, I'm using the common denominator, which is 20. So this will cancel and make that a 5. This will cancel and make that a 4. That won't cancel, but that will cancel totally. So now I've got negative 15 plus 48 over 20 plus 36.
33, I'm on.
33 over 56, how does that sound? Does that sound right to everybody? And that's it. I'm done. That's all there is. All right, next, cosine 2 alpha. So this is the one of the ones that has more than one option. It doesn't matter which option you pick. I heard somebody say 2 cosine squared minus 1. You find it on the sheet, that's one of your options. You could do 1 minus 2 sine squared, you could do cosine squared minus sine squared. It doesn't make any difference. In this problem, it truly doesn't. Be careful if you're doing this option. What is the cosine of alpha? The cosine of alpha is negative 4/5, and you're squaring that. So this means take 2 times the cosine squared, and then subtract 1. So what's the cosine squared? 16/25. 2 times that would be 32/25. 32/25 minus 25/25 is 7/25, and that's your answer. Are we okay with that?
Yeah.
last one.
Oh, wait.
Now we're using this picture.
Okay.
I got
So
you.
what's our formula?
Plus or minus root of
Plus
one
or
plus
minus
cos
1 plus cosine
beta
over
over
2. And the whole thing is under the radical. Make sure you're getting the whole number under the radical. Alright, so I'm gonna look at my picture.
5. That works.
What's the cosine of beta?
5/13.
5/13. So 1 plus 5/13 over 2.
Overall.
Multiply everything by 13. That'll kind of clean up that mess. Although it's still a mess. So what have I got? The square root of 13 plus 5 over 26. Now, don't try to cancel anything, that plus sign, but you can add those. So now we have 18, 26. Is that okay? And that plus or minus, and that's plus or minus 9/13.
Not it.
No, because it's the square root of 9 over the square root of 13. And what's the square root of 9? 3. Plus or minus. And root 13 is, what root 13?
3 root 13
So
over.
now I can rationalize, I'm gonna erase this as a one effect. Now I can rationalize and get 3 root 13 over 13 plus or minus. Now, the trig ended right here. This is where the trig ended. All the rest of this is just basic arithmetic stuff, right?
Yeah.
Now wait, we never leave an answer as plus or minus, we have to choose. So I'm gonna go back to the very beginning of the problem. It said beta is between basically 270 and 360.
Yeah.
Yeah, 3 pi over 2 and 2 pi. That's where beta is. If I cut that in half, where would half of beta be? Between 135
1,
and 180.
so 0.2.
So 135 and 180 would put it over here,
Yeah. So it'd be negative.
and cosine over here is negative. So you have to pick the negative root because we're doing a cosine problem.
Real life scenario would be me putting in money into cash register. And I have to do this math equation to figure out how much change I should get back.
You might have to. All right, let's get our practice packet back out.
Oh, yeah, I thought there was a chapter. I audio to my fingers and one
I will.
Page 4. Says pretest, 5-1 to 5-4, page 4 of your practice packet. All right, I want to focus right now on number 2. These are the verified, because on Monday, you're gonna get to do one. Okay? But I'm gonna be nice. I'm gonna give you 2 and let you pick 1. All right? But we're gonna practice right now. There's 4 of them here. We're gonna get these 4 done. All right, we're on page 4, problem 2. And we're gonna prove or verify these if I can read them. Kind of hard to read. So let's go.
It's right here.
Oh my god. Yeah, Miss Ford,
Yeah.
do we get this on Monday?
Yeah,
Okay.
you'll get you have your reference sheet.
What's on Monday? What's on Monday?
Is that cosine squared times cotangent squared?
Yeah.
All right. All right, here we go. We're kind of reviewing for the test, but we're also focusing on what our quiz will be on Monday. Okay? So, pretend it's you, it's Monday, you got this problem staring before you.
Yes.
What might you do?
Cosine squared over sine squared.
So change your cotangent into cosine squared over sine squared. Good first step.
Get
Get
common.
a common denominator. Anytime you are subtracting or adding fractions, you need a common denominator. So what will the common denominator be?
Sine squared, cosine squared.
No, the denominator.
Sine squared.
The common denominator will just be sine squared, won't it? It's cotangent.
Where's that?
Tangent is sine over cosine,
Yeah.
and cotangent is the reciprocal of tangent.
That would be 1.
So this one is good. This one needs a sine squared.
So that would be minus 1.
All right, so now I'm here.
Sine squared equals cosine minus 1. Should we do that?
We can do that. I'm trying to think what's gonna happen if we do that.
Is there an easier way?
Can you take out
I
the?
think, I hear someone
Can
saying,
you take out
oh, so I think it might be easier, Jake, to factor the numerator. Does the numerator factor?
you take out cosine?
Yeah, so I'm gonna pull out a cosine squared. And what will I have left? If I pull out a cosine squared, I'll have
1 minus sine.
1 minus, oh, wait a minute, I've heard that before. 1 minus sine squared, what is that?
1 squared.
1 minus sine
Oh,
squared.
that's
Cosine
cosine.
squared.
That's cosine squared?
Yeah.
So now I have cosine squared times cosine squared over sine squared. Now let's think about, this is where I'm going. Don't put those together because that would make a fourth, and you don't have any fourths up here. You do have a cosine squared up there, right?
Oh, it's back.
Times, what's this? Cotangent squared, so we have cosine squared times cotangent squared.
So you're just going like your data, you're just looking for like just that.
I'm just going through. When I'm grading it, I'm looking, what did he do, what did he do, what did he do, what did he do, what did he do? It may be, I don't really even have an answer key for this because
There's many ways to do
there's
it.
many ways to
It's
do
just
it.
proving, yeah.
All right, let's try the next one. I don't want you to be scared of this, guys. I want you to be kind of excited by it because it's a challenge.
1 over cosine, 1 over sine. Oh, wait, no.
Okay. So I'm gonna start over here by distributing. There's a lot going on over here. I'm just gonna distribute and at least not have parentheses. So I have sine cotangent plus sine cosine tangent. All right, still a mess, but now I don't have parentheses for you. What should I do now?
You have sign times post over sign.
Okay, so Elijah says, let's make that a fraction. So I have sine over 1 times cosine over sine plus sine over 1 times cosine over 1 times sine over cosine. Now, I've got stuff adding, but before I get a common denominator, let's cancel.
Yeah.
Won't these cancel? So over here, all I have left is cosine.
What the cosine on the right?
Yeah, cosine.
And over here, those are canceled, and all I have left is,
Sine squared.
and isn't that what I wanted? So I'm done. Are you feeling okay about that? All right, so let me just shut up, and you try number C, letter C. You see what you can do with C. Page 4, 2C is the one you're working on right now. All right, let's take attendance while you're doing that.
2C, okay. Joe Garvey just got using that particular type.
Where is Joe?
I don't know.
Look at that, he's on the board.
Oh my god, this is the first time I've ever got one right.
I told you they're fun and exciting.
Oh, I got the same thing, I got it right.
I got it wrong.
Not even realizing it.
Wait, where did you think? What
Over
was
something.
That would be the one I picked.
I don't know, I'm not looking.
Is Lockhart on vacation or
He's
what's
on
that?
retreat. He's on retreat.
He's on retreat. Well, he was sick before, or he was out before that.
Yeah, he was sick with something.
I feel like I haven't seen him
He was sick,
in a long
So
time.
fast. And then by the time I woke up, it literally was done. I'm like looking for like formula. He's giving the just being done like how you feeling when it's like I was very sorry. For the last 2 weeks, I thought, oh, that watched the video.
All right, so I heard a lot of positive things. What did you do here?
One over.
One over sine,
One over cosine.
One over
Common
cosine.
denominator, then get the answer.
common denominator is sine cosine. So this one needs a cosine, this one needs a sine. And I heard great joy, because when you put those together, you're basically done. Okay? Pat and Rock, you got it?
Yeah.
Locked in, locked. Okay, one more.
Let's try D on our
Let's try D on your own. Go ahead and get started with it, see what you can get.
Ms. Ford,
What?
is there like a number of absences you can have before you fail a class?
We have some kind of policy like that, but I don't quite know what it is. You miss so many and then you start getting a deduction every day after that, but I don't know what it is. And there's all kinds of exceptions to it, so, I don't know. Don't be absent.
Yeah.
Miss Ward has every 10 class.
Would that be you, Jay?
I mean, that's like a weird class, but okay.
How is that weird? Pretty.
Because you think you're cool because you go to school, you're not, buddy.
No.
School is not cool.
Yeah, going to school every day is cool.
Yeah.
So I'm sorry.
That's what I said, yeah.
You are wrong.
No, I
You
said,
are
I said,
wrong.
I said you're cool if you go to
You're
school.
very wrong.
You're cool if you don't go to school.
All right, let's
actually.
go. This one is going to be a bit more challenging, I can tell right off the bat. My hope is that you have done this.
I'm almost there.
I'm literally figuring it out. I'm so
Almost there.
Oh, yeah, good. All right, now,
Wait, how?
I don't want to discourage you from going off and doing this, but everybody, it seems to me, would begin this way. And they already have a common denominator, so I can just add them. Okay? Now, unfortunately, that is not what's on the other side. We talked about this. Does anybody remember the little trick we did when we get to a point like this?
Reciprocals?
We multiply something into the problem.
I just don't, how do you know when to do that? Like,
Well, what else are you gonna do here?
You can't flip it, so you have to.
There's nothing you can do with this. So what I'm gonna do is say, all right, I don't know what's going on, but I gotta have a cosine on the top.
I did that.
I have to have a cosine on the top. You cannot change a sine into a cosine because it's not squared. So the only way to get that cosine is to put it in. As long as I put it in the bottom, it's okay. All right, so now what have I got? I've got cosine, sine plus 1, over cosine squared.
wait, so sine plus 1.
Cosine squared is also known as sine 1 minus sine.
Okay.
Sine minus 1 equals cosine.
No, only if it's squared, Jake, only if it's squared. Now,
Oh, yeah,
I want you to look where we are. This is where I want to be. I don't want a cosine in my denominator, I want a sine. Luckily, that cosine is squared, so I can change it into a sine. Remember, as long as they are squared, you can change them. If they're on your formula sheet. Sine squared plus cosine squared is 1.
The difference is squared.
This is the difference of squares. So that will factor on the bottom, that will factor as 1 minus sine, 1 plus sine. And then these two are the same, and I end up with the answer. Okay? So on Monday, I'm gonna give you like a sheet of paper, and it's gonna have 2 of these on it. And you're gonna get to pick the one that, I mean, you can try them both, but hopefully one of them you'll be able to get all the way to the end. Quiz on Monday.
What if we do 2, both of them?
It depends what kind of mood I'm in. Keep me happy. We talked about that before. Okay, so we got number 2 done. All right, and everybody's clear that's what our quiz is over,
Yep.
right? You're gonna do one identity. You have a choice of 2. You'll have your reference sheet. Okay. All right, let's look at part 3. Part 3. This is different directions. This says solve. Okay. So we have sine 2x equals cosine x, and we are solving in radians. That's what these directions mean. We're in radians. For problem B, we'll be solving in degrees. All right? Now, what do I do?
Okay, cosine sine.
We can move the cosine to the other side. We like to have our equations set equal to 0. Now Now you have a huge problem. Does anybody
Two.
see what the problem is?
Two.
There's a 2. On your sheet, there's a way for you to fix that. What is the sign
Two
of
sines.
2x?
Two sines. Cos.
2 sine x cosine x.
Take cosine.
Okay?
Just
Now what can we do?
factor out a sine like that.
Factor out a what?
Cos.
Just a cosine. All we can take out is a cosine.
Can't take a sine out like that too.
No, because you gotta have a sine over here. Gotta be both sides. So you take out a cosine. What's left? 2 sine minus 1.
So both equal to 0.
Set it equal to 0. So cosine equals 0. Can I jump ahead and say sine equals 1/2? Is that too much, or can you follow that?
I call that good.
When x is 0 is at pi.
Now zeros, remember, aren't triangles. Zeros are somewhere around here.
So pi over 2 is
Cosine is x, and that's here and here. So my angles are pi over 2 and 3 pi over 2,
and then sine is y.
right? Now, 1/2 are not on the circle. 1/2 I have to figure out which quadrants, 1 and 2, sine is y, y is positive in 1 and 2. Opposite hypotenuse, how big's that angle? 30, but remember we're in radians, so that would be pi over 6, 180 divided by 6. So we have pi over 6, and think now, don't rush, don't panic. All the way to here is pi,
5 pi.
but it's 1/6 less than that, so it's 5 pi over 6. Anybody have a question about that? Okay, this is different than your quiz, right? This is solving the equation x equals. Your quiz, you're just simplifying things. All right, one more. Let's do one more problem. We've done a lot today. One more. You will need a calculator for this one, I can tell. So get your calculator out. Put it in degree mode, because this is a degree problem. Okay? Thoughts about how we're going to do this problem?
Factor.
Factor, all right. How does it factor?
Tan and a tan, 5 and a 1. A negative 5 and a positive 1. Tan equals was
Just a
it?
second. Does everybody agree with the factoring? It looks right.
It looks right, or is it?
So we can go with it looks right, or we can actually foil it, right? Check it out. It is right.
It is right.
It is correct.
So
So tan equals 5, and tan equals -1. Now, that one you can do without a calculator.
yeah.
Where is the tangent negative?
Left.
Left.
2 and 30. 2 and 30. Oh, 2 and 4. My bad.
So.
I bet you're
God,
right.
Dana.
Oh.
Hey, what is that?
Come on, we're gonna get this done. Is everybody okay? Remember tangents, y over x?
Yeah.
And I need one positive and one negative for that to happen. Okay, now if it's 1, then these are both 1s. How big of an angle has a 1 and a
45.
45. But what will the answers actually be?
Oh, that's 100.
This one would be 135. And then this one would be 315. So stop the mumbo jumbo. I want everybody paying attention. We got 135 because this angle is 180 minus 45. And this one is 360 minus 45. All right, now, I need a calculator for this one because if I drew my pictures, and I do need to know quadrant 1 and 3, but it's 5 and 1. That is not one of my angles. So how am I going to use my calculator to find that angle? Second tangent 5, exactly. Make sure you're in degrees, and then second tangent 5. 78.69. So what are our two answers? 78.69 and 258.26 or 0.69. How did you get 258? 78 plus 180? So 4 answers to that problem. There they are. All right, I'll stop, I promise. So I will.
Oh my god.
Yeah, thank you. No, 5-4 will be due on Tuesday. So 5-4 is due on Tuesday, but we have a little identity quiz on
I got a 20
Monday.